नमस्कार दोस्तों, वेलकम टू गेट वाला। मैं हूं सतीश कुमार द्विवेदी, फैकल्टी ऑफ मेजरमेंट्स एंड इंस्ट्रूमेंटेशन। कैसे हो सब लोग? आज हमारा लेक्चर नंबर 2 स्टार्ट हो रहा है, पार्ट नंबर 2। कल हमने मेजरमेंट्स का पूरा सिलेबस का डिस्कशन किया है, ब्लूप्रिंट का सिलेबस का ब्लूप्रिंट डिस्कशन किया है। आज हम डिस्कस करेंगे फर्स्ट टॉपिक, दैट इज ब्रिजेस। ओके, सो बहुत सारा क्वेश्चंस गेट के लेवल पे हो और आईएएस के लेवल पे हो, बहुत सारा क्वेश्चंस आ रहे हैं। सो वी विल डिस्कस दोस क्वेश्चंस अभी इन दी लेक्चर नंबर 2। सो लेक्चर नंबर रिकैप ऑफ प्रीवियस लेक्चर में क्या डिस्कस किया। सो प्रीवियस लेक्चर में हमने डिस्कस किया है जस्ट अ सिलेबस कवरेज, सिलेबस फॉर बोथ EE and instrumentation. Next, static characteristics of instruments, and dynamic characteristics of instruments we have discussed. Okay, so this was the last topic that we have discussed. Okay, ऑडियो वीडियो सब कुछ क्लियर है? मुझे एक बार कंफर्मेशन कर दीजिए बेटा, जितने लोग लाइव में सेशन को देख रहे, एक बार मुझे ऑडियो वीडियो कंफर्मेशन दीजिए बेटा। Okay, Gautam, thank you very much. Thank you. So now we'll discuss bridges in brief, क्योंकि in YouTube sessions we are going to cover a brief idea. Okay, so recap of previous lectures, and आज हमने topics to be covered, we are going to discuss majorly the topics of bridges. We are going to cover the topics of bridges. So what are those topics? Let us see. Those topics are DC bridges as well as AC bridges. Okay, so DC में हमको बहुत सारा लिस्ट है, डीसी में हमारे साथ बहुत सारा लिस्ट है, एसी ब्रिजेस में भी बहुत सारा लिस्ट है। सो थोड़ा सा जितने लोग लाइव में हैं, एक बार आपका इंट्रोडक्शन दीजिए, आप कहाँ से हो, आप बीटेक पढ़ रहे हो और बीटेक कंप्लीटेड है। ओके, मुझे एक बार कंफर्मेशन कर दीजिए बेटा। ओके, आई विल बी वेरी हैप्पी दैट इफ यू आर इंटरेक्टिव इन द सेशन. So I always expect the interaction in the sessions, even though it's a YouTube session, we need interaction. Chalo. So in the DC bridges, the major thing that we are going to get here is the Wheatstone bridge. In the DC bridge, what we are going to get is the majorly the Wheatstone bridge. And we are going to get the Kelvin bridge. So these are the major in DC bridges. What are the major bridges that we are going to get the questions are Wheatstone bridge and Kelvin bridge. Basically, what is the purpose of these bridges? These bridges are suitable for measurement of resistance, inductance, capacitance. Okay, so majorly what I mean to say, AC bridges majorly they are suitable for majorly suitable for resistance, inductance, capacitance measurement. DC bridge is majorly suitable for only for resistance measurement. Okay, So only 2 bridges are majorly important in DC. बीटेक सेकंड ईयर जस्ट कंप्लीटेड. ओके, सो आपको ये सेमेस्टर में ये सब्जेक्ट होगा शायद, अगर थर्ड सेमेस्टर में ये सब्जेक्ट होगा. सो आप ध्यान से ये क्लास सुनो तो आपका सेमेस्टर का एग्जाम्स को भी आपको ये यूजफुल होगा. ओके, एंड एसी ब्रिड्जेस में क्या होगा बेटा? एसी ब्रिड्जेस में हमारे पास मैक्सवेल इंडक्टेंस ब्रिज है. मैक्सवेल इंडक्टेंस ब्रिज, मैक्सवेल इंडक्टेंस ब्रिज and Maxwell inductance capacitance bridge, Maxwell inductance capacitance bridge. ओके, एंड इसके साथ हमारे पास है हेस ब्रिज. ओके, नेक्स्ट Anderson bridge. Next, Owens bridge. Sharing bridge, sorry, DSOT bridge. इसके बाद शेयरिंग, इसके साथ वीन्स ब्रिज. ओके, सो दीज ऑल आर द ब्रिजेस माय डियर. एक बार लिस्ट आउट कर लो बेटा पूरा ब्रिजेस का. ओके, प्लीज नोट डाउन कर लो एक बार. कल थोड़ा बफरिंग का इश्यू आया था, आई एम वेरी सॉरी फॉर दैट. सो दैट्स व्हाई आई हैव शिफ्टेड दिस टाइमिंग्स टू 9 o'clock. ओके, Pramit Banerjee, IIT Kharagpur. Sir, I was your previous student. I am doing MTech in IIT Kharagpur. I studied measurements and sensors and transducers from you. Sir, could you suggest me preparation for 𝐂𝐨𝐻𝐿𝐴 measurement subject? Pramit Banerjee, love you. I wish you all the best. IIT Kharagpur, I think you are doing MTech. Okay? Okay. MTech in which branch, may I know? Okay. So I wish you all the best and thanks for your feedback. Okay. Next, another person is asking for 𝐂𝐚𝐭, 𝐂𝐨𝐻𝐿𝐴, Telangana State 𝐂𝐚𝐭. I think it is Telangana State. Mr. Kingston, it is Telangana State 𝐂𝐚𝐭. 𝐂𝐚𝐭 and Transco, for all these exams, my classes are more than enough. My classes are more than enough. Whatever the platform you are getting on the YouTube channel. So if you go through that YouTube channel, you can get the content. Okay. So my dear students, these are the major bridges. So jo exam, whatever the exam that control systems, very nice branch, very nice branch. Focus on the campus placement, Pramit Banerjee. So I think you are in a good platform now. You are good domain now, control system. But at the same time, आपका कैंपस प्लेसमेंट बहुत इंपॉर्टेंट है, क्योंकि ये बीटेक से हमको कैंपस प्लेसमेंट जो मिलता है एंड एमटेक से जो कैंपस प्लेस मिलता है उसमें थोड़ा सा डिफरेंस है. एंड आई सजेस्ट गो फॉर दी मल्टी डिसिप्लिनरी ओरिएंटेड जॉब्स. ओके, जो ड्रोन्स के ऊपर, आई एम ऑल्सो रिसर्च स्कॉलर ऑन द ड्रोन्स. सो एट प्रेजेंट आई एम डूइंग माई PhD ऑन द UAV, okay, unmanned aerial vehicles. So which is the latest trends that are happening in the technology. So please उसके ऊपर ध्यान करो. So जो कंपनीज आ रहे हैं आपका IIT खड़गपुर पे, IIT खड़गपुर दो साल और 2.5 years का जो टाइम स्पैन है वो बहुत इंपॉर्टेंट है. ओके, वो टाइम पर आपको वो यूनिवर्सिटी में, वो IIT में आपको क्या क्या मिल रहे हैं अपॉर्चुनिटीज, क्या क्या वर्कशॉप्स अटेंड करने की चांस है, जहां आपको वेबिनार्स अटेंड है, जूम सेशंस है एंड इंटर्नशिप्स है, जो भी हो प्लीज ट्राई टू अटेंड. ओके, once you have gone through the campus placement, then your actual journey starts. So I'm very happy that one of my previous student is attending this YouTube session. He's giving good compliments for us. Very happy for that. Okay, and जो people 𝐂𝐨𝐻𝐿𝐴 तेलंगाना स्टेट 𝐂𝐚𝐭 के लिए क्वेश्चन पूछ रहे, ये सेशंस मोस्ट वैलिड सेशन है. एंड ये सेशन नहीं, हमारा फिजिक्स वाला चैनल पर, गेट वाला चैनल पर एंड पूरा जो प्लेटफॉर्म अवेलेबल है उसमें हमारा यूट्यूब पर मेजरमेंट्स का बहुत सारा कंटेंट अवेलेबल है. द बेस्ट कंटेंट इज अवेलेबल ऑन द यूट्यूब प्लेटफॉर्म फ्रॉम माई साइड. वो प्रिपेयर कर सकते हैं आप. इट्स ए frame lokesh on earth. It is just like a time bound course, so within some 10 hours or within our 15 hours we are taking daily 1 hour 10 minutes like that. So within 15 hours जितने topics cover होगा वो मैं खत्म वो complete करने की कोशिश करूँगा. So it's not, I'm not guaranteeing that I'm not going to cover entire course on the YouTube. So just a glimpse I'm going to give so that आपको थोड़ा refreshing तरफ से and syllabus का जो coverage है ना वो मिलता है. इन डेप्थ हम ना दे सकते क्योंकि हमको डेली 1 hour 30 minutes ऐसा है टाइम. सो इसके लिमिटेड सेशंस में हम आपको पता है ना जो रिसोर्सेस है हमारे पास इसके अनुसार. ओके चलो माय डियर. सो फर्स्ट वी लेट अस स्टार्ट विद द डीसी ब्रिजेस. ओके सो लेट अस स्टार्ट विद द डीसी ब्रिज. फर्स्ट मोस्ट इंपॉर्टेंट ब्रिज इज द व्हीटस्टोन ब्रिज. ओके सो ऑन व्हीटस्टोन ब्रिज फंडामेंटली मेनी क्वेश्चंस आर एक्सपेक्टेड. ओके सो क्योंकि ये एरिया है ना ये एरिया आपको नेटवर्क से मिलके क्वेश्चंस आने की चांस है. ये एरिया में आपको बहुत सारा न्यूमेरिकल प्रॉब्लम्स फेस करने की चांसेस भी बहुत सारा हो सकता है ये पर्टिकुलर व्हीटस्टोन ब्रिज में. तो इसलिए मैं क्या बोल रहा हूँ आपको थोड़ा सा ध्यान से सुनो. व्हीटस्टोन ब्रिज में 4 रेसिस्टर्स होता है ऐसा. So this is a Wheatstone bridge diagram. So basically Wheatstone bridge is not operated by AC supply, whereas the other bridges are completely operated by AC supplies. So ये एक बार ध्यान से देखो ये particular bridge है ना, this is completely operated by DC supply. This is completely operated by DC supply. So this is plus and minus, this is Vs. So if you see, this is R1 and this is R2, this is R3, this is R4. Okay, and we are keeping a galvanometer here. Two conditions hai. One is the meter resistance can be infinite. Two conditions hai. One can be the so this is our meter resistance Rm. Okay, so now if you, I'm not going to much into derivation part, so directly I will go for the content. So this is a major current I. So this I is going to split into two parts. This is I1 and this is I2. This current goes like this, this current goes like this. So this is the path for this current, this is the path for this current. Okay my dear, so this is the meter resistance. So this is our Rm. Yeah, thank you. Please make a note of this picture once again. जितने लोग सेशन को देख रहे, एक बार आपका दोस्त के लिए, आपका फ्रेंड्स के लिए ये सेशन शेयर करने की कोशिश करो बेटा. I will be more happy if you share this session to your nearest and dearest. चलो, yeah. So if you see, suppose when the bridge is balanced, suppose at the bridge is balanced, so if bridge is balanced, that means if VAB and VAD, that if you see the VB minus VD is equal to 0, VB minus VD is equal to 0, then the galvanometer deflection will be 0. So the V bridge will be 0. V bridge will be 0. So what is VB? That VB is equal to I1 into R2, okay, plus VC minus VD यहाँ से I2 into R4 प्लस VC. थोड़ा सा एडवांटेज क्या है ना, ये टॉपिक के लिए आपका नेटवर्क्स का लॉजिक यूज कर सकते हैं. ओके, सो दिस आई कैन टेक इट एज I1 R2 प्लस VC माइनस I2 R4 माइनस VC इज इक्वल टू 0. सो यहाँ से आपको क्या निकाल सकते हैं, ये VC एंड ये VC गेट्स कैंसल. So I can write here this as I1 R2 is equal to I2 R4. So what is I1? I1 I can write it as Vs by R1 plus R2 into R2. What is I2? I2 I can write it as Vs by R3 plus R4 into R4. So the bridge balance condition निकाल सकते हैं आप यहाँ से R2 R3. जितने बच्चे लाइव में है थोड़ा सा एंकरेज कर दो बेटा सेशन को. आपका जो डाउट्स है वो पूछ सकते हैं, आप हमारा डाउट्स पूछ सकते हैं. ओके, R2 R3 प्लस R2 R4 इज इक्वल टू R1 R4 प्लस R2 R4. सो यहाँ से हम क्या निकाल सकते हैं, ये R2 R4 को कैंसिल कर सकते हैं. सो आपको ये मिला है अभी एकदम R1 R4 is equal to R2 R3. So this is the basic bridge balance condition. Okay, so in this, suppose if this is your unknown resistance, suppose this is your unknown resistance, automatically so this particular resistance you can take it as unknown resistor. So R4 is our unknown resistor. R4 is equal to R2 R3 by R1. So Wheatstone bridge null method is suitable for what? For finding the unknown resistance. Very good. Yes, I am from Odisha sir, last year BTech. Okay, ये सेशन आपको यूज होगा. जितने लोग इलेक्ट्रिकल बच्चे वो बच्चों के लिए ये सेशन बहुत अच्छा यूज होगा. नेक्स्ट, सपोज द ब्रिज इज not perfectly balanced. Suppose if the bridge is not perfectly balanced, so that means what? If VB is not equal to VD, then the V bridge will be the deflection, that is VB minus VD hoga. So as per the previous just data, I can take it as VB minus VD. So VB is this I1 R2 plus IC, I1 R2 plus VC, and VD I can take it as I2 R4 plus VC. This I can take it as I2 R4 plus VC. So यहाँ से आप निकाल सकते हैं ऐसा I1 R2 plus VC minus I2 R4 minus VC. So you can eliminate this. So if I take this as I1 R2 minus I2 R4, so what is the I1? I1 is nothing but Vs by R1 plus R2. Okay, so fatafat. So this is Vs by R1 plus R2 into R2 minus what is I2? That is Vs by R3 plus R4. This is Vs by R3 plus R4 into R4. So now if I am taking the V bridge, that is Vs into R2 by R1 plus R2 minus R4 by R3 plus R4. So my dear students, please note down this formula, that is the bridge, unbalanced bridge expression. So if you can remember this formula in GATE exam, you can solve n number of questions on this particular context. Okay, so that is the Wheatstone bridge voltage. All of you clear my dear? So clear है तो मैं कंटिन्यू मैं करता हूँ. So क्या लिख सकते इधर? So V bridge is equal to Vs into R2 by R1 plus R2 minus ये R4 by R3 plus R4. So यहाँ से suppose कोई ना कोई resistor, suppose initially if R1 is equal to R2 is equal to R3 is equal to R4 is equal to R, then what happens? This V bridge will become 0. Okay, yeah? Are you following my dear? Confirmation कर दीजिए बेटा, जितने लोग लाइव में हैं मुझे एक बार confirmation कर दीजिए बेटा, इतना डिस्क्रिप्टिव में जा रहा हूं मैंने. Suppose if R2 is changing as some modified resistor R plus delta R, whereas remaining R1 and R3 and R4 are unchanged to R, then क्या होगा V bridge? Very interesting यहाँ. So this is Vs and this R2 I can take it as R plus delta R divided by this is R, this is R plus delta R minus ये R, this is also R, this is also R. So now if we check, this is Vs, this is R plus delta R, this is 2R plus delta R minus 1 by 2. So now if I am doing this, what I'm going to get 4R plus 2 delta R. So this I can take it as 2R plus 2 delta R minus 2R minus delta R. So here 2R gets cancelled. So this bridge voltage I am going to get it as Vs into delta R divided by 4R plus 2 delta R. So in short, I can take V bridge as quarter bridge expression I can take here, generally in the denominator. So V bridge I can take it as Vs by 4 into delta R by R, ऐसा लिख सकते हैं. Vs by 4 into delta R by R. So this is what we call as quarter bridge. Please note down one of the interesting formulas I am telling my dear. These formulas are shortened formulas, shortened tricks. अगर आपको कोई ना कोई एग्जाम है, अगर आपको कोई ना कोई एग्जाम में ऐसा एक न्यूमेरिकल प्रॉब्लम आ गया, देन आराम से ये फॉर्मूला यूज कर सकते हैं. चाहे क्वेश्चन नेटवर्क थ्योरी हो, मेजरमेंट्स हो, और जो भी एक सब्जेक्ट हो उसमें आपको ये फॉर्मूला आप यूज कर सकते हैं. मजा आ गया. ओके, चलो, all of you clear up to this? So if you are clear, then I will go for a question. Answer this question. ये क्वेश्चन IIT खड़गपुर 2006 का क्वेश्चन है. प्रमित, आपका खड़गपुर का क्वेश्चन है. ट्राई टू आंसर दिस क्वेश्चन. आंसर बताइए बेटा, आई एम वेटिंग फॉर योर आंसर। क्या हो गया यार, सिंपल कॉन्सेप्ट यूज कर सकते हैं नेटवर्क थ्री का। ओके, द आउटपुट रेसिस्टेंस अक्रॉस द टर्मिनल्स 1 and 2 फॉर द डीसी ब्रिज ही इज आस्किंग। ओके, तो कैसे करेंगे क्वेश्चन को, नेटवर्क थ्री का कॉन्सेप्ट यूज करो। नेटवर्क थ्री का कॉन्सेप्ट यूज करके बताइए। चलो कैसा करना है इस क्वेश्चन को, जस्ट यू हैव टू शॉर्ट दिस, how to use this. So if you short this, then what happens, this particular, if you short this now, then what happens, so this one, this 20k and this 30k will be parallel. Okay, and again this section 25k parallel. Networks ka concept, if you short this supply, then automatically these particular things will be in parallel and the combinations will be in series. So if you see this now, this is 25k, this is 25k. So what is the parallel combination of this? So the R equivalent will be 20 into 30 divided by 20 plus 30, that is 50, plus 25 into 25 divided by 60, so this is 12.5. So कितना होगा 600 by, so answer will be 24.5 kilo ohms. Very simple question. So this is the way you are going to get the questions now. सिंपल नेटवर्क्स का कॉन्सेप्ट यूज करते हैं, लेकिन ये ब्रिजेस के ऊपर आएगा क्वेश्चंस। ओके, so the answer is 24.5 kilo ohms. या कबीर देखो, नेटवर्क्स का कुछ कॉन्सेप्ट है ना, so you have to short this. When you short this, these two resistors will be in parallel and these two resistors will be in parallel, and the combination is, because he is asking it just like the R Thevenins. We are calculating the R Thevenins. नेटवर्क्स में आपको थेवेनिन्स तो थोड़ा सा आइडिया है तो आप बोल सकते हैं। एस किंगस्टन इज नॉट 25, इज 24.5, दिस इज 12.5 and this is 12, so 24.5. Is it clear? Very good Kabir. Yes, nice. Okay, तो और एक क्वेश्चन को जाएंगे। Try to answer this question फटाफट। मेजरमेंट्स इज ऑल अबाउट प्रॉब्लम्स माय डियर। मेजरमेंट्स में थ्योरी का, एस थ्योरी भी है, लेकिन कॉम्पिटिटिव एग्जाम्स में थ्योरी के कंपेरेटिवली आपको यहाँ क्वेश्चन ज्यादा आने के चांसेस है। एस कबीर, When the Wheatstone bit shown in the figure is used to find the value of resistor Rx, the galvanometer G indicates so very interesting question. This is how to understand the question. When the Wheatstone bit shown in the figure is used to find the value of resistor Rx, so this is the Rx. Let us take, so this resistor is the Rx. Okay, so this Rx we have to find. So the galvanometer G indicates zero current, so this is zero, that means the bridge is balanced. If the bridge is balanced, what I can write here? If the bridge is balanced, what I can write? So I can write like this. So this is R1 Rx is equal to R2 R3. R1 Rx is equal to R2 R3. So Rx will be equal to R2 R3 by R1. These are the opposite terms. Okay. So R1 into Rx is equal to R2 into R3. So Rx will be R2 R3 by R1. So what is R2 here? So if you check the values, he has given clearly the values. R1 is equal to 50 ohms. This is 50, and R2 is equal to 65 ohms, and R3 is equal to 100 ohms, and Rx we don't know. So what we have to write here? What is the range? If R3 is known, with plus or minus 5% tolerance, but if you see this R3 alone, this is having plus or minus 5% tolerance. So very interesting. So remaining all other resistors, there is no tolerance. So what is the R3 value? So if you check the R3 value, so let me write in another slide. So R3 has given as 100 plus or minus 5%. So what is this tolerance? That is error. Okay, there may be some measurement error in the R3 value. So R3 value किसका दिया है? 100 ohms plus or minus 5% दिया है on its nominal value of 100 ohms. So 5% of this, that means what? 100 plus or minus 5 by 100 into 100. So that will become as 100 plus or minus 5. So that will become 95 or 105 ohms. Okay. So now how to calculate this our Rx? So ये है हमारा Rx. Rx is given as R2 R3 by R1. Okay. So ये है हमारा सेशन. Option A, Kabir. Okay, very good. So Rx is equal to R2 R3 by R1. So I can write Rx is equal to R2 R3 divided by R1. So you can take two conditions for R3. So whereas R2 is equal to what? R2 is equal to 65 divided by what is R1? R1 is equal to 50. And R3, how much we can take? R3 either you can take it as 95, okay, or this one again same, this is 65 by 50, and in the place of 95 we can take it as 105. Okay, so now what is the answer? Please use a calci. आपके पास कैल्सी है तो कैल्सी यूज करके बताइए बेटा कितना आ रहा है. इसके पास कैल्सी है, परफेक्ट कैल्सी यूज करो बेटा. $123.5. $136.5. So 123.5 to 136.5. So option E. Very good Kabir, super. So option A is the right answer. Perfect. Perfect. Odi Lucky official, Kingston 123, Kabir, सब लोग जितने लोग लाइव देख रहे हैं, थैंक यू वेरी मच, थैंक यू वेरी मच. चलो, लेट अस गो फॉर द नेक्स्ट क्वेश्चन. वन मोर क्वेश्चन. Try to answer this question. IIT Bombay 1999. Very interesting questions I have given. IIT Bombay 1999. Try to answer this question. Anybody can answer this question? I'm giving 1 minute time. The bridge circuit in figure is balanced. The value of current is dash. The value of current I, total I is asking 2 milliamperes, 4 milliamperes, 5 milliamperes, 6 milliamperes. Okay. How to solve this question? If you see, P1 is not mentioned, that is not necessary. Yeah. Balanced. So it is balanced means what? If you take this as A, if you take this as B, take this as C and this as D. So V bridge is balanced. So V bridge is equal to what? Either you can take these two terminals VBC minus VCD, ऐसा भी देख सकते हैं. So if you take the total current I1, I is split into two parts here. This is I1 and this is also I1. This is I2. Of course, he is in 2 volts and this is I2. So what I can write here, first of all, this I1 VBC minus VCD is equal to 0. That means VBC is equal to VCD. So what I can write here, I1 into 4K. I observed this current is going like this. So this current is coming like this. So what I can write here, I1 into 4K is equal to I2 into 2K. So अब ये दोनों के बीच में एक रिलेशन आएगा आपको. ओके, सो ये दोनों के बीच में रिलेशन आएगा. ये K कट हो जाएगा. सो ये 2 कट हो जाएगा. या हमको 2 आएगा. सो हमको क्या आ रहा है भैया? I2 is equal to 2I1 आ रहा है. So we got a fundamental relation between the two currents. I2 is equal to 2I1 आ गया. लेकिन ये क्वेश्चन में क्या पूछ रहे हैं? क्वेश्चन में I पूछ रहे हैं, टोटल I पूछ रहे हैं. So if you see this voltage, VAD voltage, again इसमें भी आपको KVL का अप्लाई कर सकते हैं. अरे पूरा नेटवर्क्स का कॉन्सेप्ट है. हमारा PW में नेटवर्क्स का महारथी फैकल्टी है. सो अगर नेटवर्क्स का क्लासेस, अगर नेटवर्क्स का कॉन्सेप्ट आपको क्लियर कट है ना, मेजरमेंट्स का क्वेश्चन सॉल्व करना ईजी है. ये IES में this time in the month of June, sorry, in the last April May इस समय IES में हमको 24 क्वेश्चंस आ गया. हाईएस्ट वेटेज पूरा ऑब्जेक्टिव एंड कन्वेंशनल मिलके 96 मार्क्स आ गया मेजरमेंट्स में. मेजरमेंट्स इतना तगड़ा वेटेज है बेटा. तो ध्यान से सुनो, गेट में इलेक्ट्रिकल को कम वेटेज है ऐसा सोचते बच्चों. लेकिन अगर आपने एसएससी, जेई, एपी जन को, ट्रांसको जन को, एनी स्टेट वाइड इलेक्ट्रिसिटी बोर्ड एग्जाम लिख रहे, उसी समय आपको ये पर्टिकुलर सब्जेक्ट आपको खतरनाक स्कोरिंग देगा, क्योंकि क्वेश्चन जो आ रहा है ना डायरेक्ट हिट टू हिट क्वेश्चन आएगा। सो यहां भी आप देख सकते हैं। सो दिस इज I1 into, I can write here one more relation, same to same here I can apply. So VAB is equal to VAD. So I1 into 1 kilo ohm is equal to VAD, that is 2 volts. Okay, so यहां से आप ये एक अप्लाई कर सकते हैं। So I1 is equal to 2 milliamperes. आपको आ गया, दैट्स इट, I1 is equal to 2 milliamperes. So आपको I1 आ गया। आपको एक बार I1 आ गया, why? Because this 1k it goes to the right side, 2 by 10 to the power 3 comes to the numerator, 2 into 10 to the power minus 3 milliamperes. So I1 is equal to 2 milliamperes. What is I2? I2 क्या होगा, यहां से आप देख सकते हैं, I2 is equal to 2I1. I2 is equal to 2I1. ये क्या होगा, 2 into 2, 4 milliamperes होगा। ओके बेटा, सो दिस इज I2। लेकिन क्वेश्चन क्या पूछ रहे बेटा, क्वेश्चन इज आस्किंग द I, सो वेयर I कैन बी रिटन दैट I1 प्लस I2। यहां से आने के बाद इन स्प्लिट हो रहे हैं ना, सो कैपिटल I इज इक्वल टू 6 milliamperes। मजा आ गया। सो वेरी गुड क्वेश्चंस, क्वालिटी क्वेश्चंस। सो 6 milliamperes इज द राइट आंसर। ऑप्शन डी इज द राइट आंसर। ऑप्शन KCL विल सॉल्व। ओके, वेरी गुड, वेरी गुड। आंसर कितना आ गया सब लोगों को, डी आ गए नहीं ऑप्शन? अरे ऑप्शन तो अब तक नहीं आंसर बताया आपने, नोबडी हैज गिवन। चलो, let us go for the next question. Yeah, try to answer this question. IIT रूरकी 2017 का सवाल है। IIT रूरकी 2017 का सवाल है। I am giving 2 minutes of time. Answer me. I am giving 2 minutes of time for your answer. जितने लोग लाइव में देख रहे हैं, एक बार क्या क्वेश्चन दिया देखो। क्वेश्चन में द अनबैलेंस्ड वैल्यू, अनबैलेंस्ड वोल्टेज of the Wheatstone bit shown in the figure is measured using a digital voltmeter having infinite input impedance and a resolution of 0.1 millivolt. If R is equal to 1000 ohms, then the minimum value of delta in ohms to create a detectable unbalanced voltage. कैसा करना बेटा, आंसर बताइए। कोई आंसर सही कर रहे हैं अभी? Answer is 0.22. Okay, Kingston is telling 0.22. Let us see here. The unbalanced voltage of the Wheatstone bit shown in the figure is measured using a digital voltmeter having infinite input impedance. Infinite impedance. So Rm is infinite. So I can say that Rm is infinite. And a resolution of 0.1 millivolt. So resolution, he has given the resolution as 0.1 millivolt. What is resolution, my dear? Resolution is nothing but the smallest increment in the voltage that it can detect. The smallest increment in the voltage that it can detect is 0.1 millivolt. So if R is equal to 1000 ohms, so this is 1000, this is 1000, this is also 1000. Okay, then what is the delta R? So the minimum detectable voltage, generally V bridge. What is a V bridge formula? That is quarter bridge formula use कर सकते हैं हम, Vs by 4 into delta R by R. So here the supply voltage is 2, R is equal to 1000. So he is asking the delta R which can create the minimum detectable voltage. The minimum detectable voltage is nothing but the resolution. The resolution is given as 0.1 millivolt. So if you take the minimum detectable voltage as 0.1 millivolt and the supply voltage as 2 and by 4, so this is a delta R, we don't know. R is equal to 1000. अभी क्या होगा? This is 2. So 0.2 होगा ना? 0.2 होगा delta R. Delta R is 0.2 भैया. 2.2 कैसा आएगा? 0.2 आएगा रे किंगस्टन. 0.2 आएगा. Yes, very good. 0.2. बेटा, you should not give the comment. You should give the direct answer. Okay? Excellent, Kingston. Superb. Pramit Banerjee, are you there? Okay. Chalo. So these are the some important things. Now let us go for the next topic, that is AC bridges. So if you see the list of the AC bridges, बहुत सारा list है. So AC bridges में क्या क्या है? देखो. So first AC bridges में हमारे पास Maxwell inductance bridge है, Maxwell inductance capacitance bridge है, ACE bridge है, Alderson bridge भी है. Okay. So first if you see this one, AC bridge का basic difference क्या है? DC bridge में हमको supply voltage DC है, DC detector use करते हैं, and AC bridge में हमको supply voltage AC है and detector भी अलग अलग detectors use करते हैं as per the frequency. हम PMMC use नहीं कर सकते यहाँ. Okay, so one of the important key point I want to tell you, AC bridges में DC bridges के बीच में अंतर क्या है? तो DC ब्रिज में हम DC सप्लाई यूज कर सकते हैं. सो DC सप्लाई बोल तो फ्रीक्वेंसी 0 हर्ट्ज है. ओके. AC ब्रिज में हमने AC सप्लाई यूज कर सकते एंड AC ब्रिज के डिटेक्टर जो है ना, डिफरेंट फ्रीक्वेंसी के लिए डिफरेंट रेंजेस में यूज करना पड़ेगा. ओके. सो इसको DC ब्रिज को मेजरली फ्रीक्वेंसी 0 होना है. दैट्स व्हाई द ओनली डिटेक्टर अवेलेबल फॉर द DC ब्रिजेस इज अ PMMC. Permanent magnet moving coil instrument cannot be suitable for measuring the AC. Okay, it is only suitable for DC, so that detector we can use here as a voltmeter. So that is a point. And the bridge balance condition क्या है यहाँ? R1 R4 is equal to R2 R3. Okay, क्योंकि it contains only the components of resistors. But whereas here different detectors are used as per the frequency range. Okay, and here in the place of R1 R4 we are having the impedance Z1 Z4 is equal to Z2 Z3. So ध्यान से देखो बेटा, here phase angle भी रहेगा. तो इसका phase angle θ1 and इसका phase angle θ2 and इसका phase angle θ3 आएगा and इसका phase angle θ4 रहेगा. So if you see now, so phase angle 1 plus phase angle 4 is equal to phase angle 2 plus phase angle 3. So this is the conditions for the this one. Next, what are the other measurements we are going to do? We are going to get resistance measurement, inductance measurement, capacitance measurement, frequency measurement, Q factor measurement, dissipation factor, DF बोलो तो dissipation factor. Try to understand. This is क्या है? Dissipation factor. And इसके साथ साथ हमको relative permittivity भी आएगा. Relativity, permittivity. So these are the other measurements that we are going to get here. Is all okay? चलो नाउ लेट अस गो फॉर सम थियोरेटिकल। एसी ब्रिज में क्या क्या डिटेक्टर्स है, यू सी द डिटेक्टर्स। सो डिटेक्टर्स क्या क्या है, सो उसका फ्रीक्वेंसी है वाइब्रेशन गॉल्वामीटर, इसका फ्रीक्वेंसी रेंज है 2 Hz to 100 Hz। वेरी वेरी इंटरेस्टिंग, दिस डाटा इज वेरी वेरी इंटरेस्टिंग माय डियर। अगर आपने प्रीवियस आईएएस और प्रीवियस जेनको का पेपर्स देख लो, आपको कितना बार ये क्वेश्चंस आगे आपको मिलेगा। ओके, so you can see how many times we got the questions. So vibration galvanometer is 2 to 100 Hz. Headphone galvanometer is a detector suitable for 250 Hz to 4 kHz. Okay, tunable amplifier galvanometer is from 100 kHz तक जलेगा। Okay, suppose if your measurement is in the range of megahertz, then you can go for CRO, cathode ray oscilloscope. Okay, so vibration galvanometer is 2 to 100 Hz. Headphone galvanometer is from 250 Hz to 4 kHz. Tunable amplifier galvanometer is 10 Hz to 100 kHz, and cathode ray oscilloscope is in the range of megahertz. Okay, megahertz. Now let us start with the first one, the Maxwell inductance bridge. So if you see the Maxwell inductance bridge, it is not combination of only resistor, it is a combination of inductive component, like which is having some frequency component, impedance component. So here this is our test coil. In test coil we have a resistor, we have an inductor. So हमको ये parameters हमको पता होना है. So we need to know these parameters R and L. Okay, and this one I can take it as R1 plus j omega L1. एंड इसको फाइंड आउट करने के लिए, ये अननोन है, ये अननोन को फाइंड आउट करने के लिए हमने नोन पैरामीटर्स को यूज कर सकते हैं। दो कॉम्बिनेशंस है, मैक्सवेल इंडक्टेंस ब्रिज एक कॉम्बिनेशन है, मैक्सवेल इंडक्टेंस कैपेसिटेंस ब्रिज और एक कॉम्बिनेशन है। मैक्सवेल इंडक्टेंस ब्रिज में टू फाइंड आउट द अननोन इंडक्टेंस विल यूज द नोन इंडक्टेंस। मैक्सवेल इंडक्टेंस कैपेसिटेंस ब्रिज में टू फाइंड आउट द इंडक्टेंस विल यूज द अननोन कैपेसिटेंस। By comparing with the inductance, we are going to measure the another inductance, that is Maxwell inductance bridge. By comparing with the capacitance, we are going to measure that is MIC. So ये try to understand. Maxwell में हमको दो bridges हैं, Maxwell inductance bridge है, Maxwell inductance capacitance bridge है। Maxwell inductance bridge में unknown inductance को हमने by comparing with the known inductance we are going to do Maxwell inductance capacitance में with capacitance. Okay, चलो very simple की बात है। So Z1 R1 plus j omega L1 होगा, and Z2 R2 plus j omega L2 होगा, Z3 is nothing but R3, Z4 is nothing but R4. So at balance Z1 Z4 is equal to Z2 Z3 बनेगा। So अगर आपने थोड़ा सा सिंप्लीफाई करके देखो, so these are all the simplification I have given here. वेरी सिंपल। अगर आपको एग्जाम में क्वेश्चन आ गया, न्यूमेरिकल क्वेश्चन आ गया, नो नीड टू बाय हार्ट ऑल दिस फार्मूलाज, यही फॉर्मेट यूज करके, यही मेथडोलॉजी आप यूज करके डायरेक्टली आपने प्रॉब्लम्स को सॉल्व कर सकते हैं। ओके बेटा, सो Z1 Z4 इज इक्वल टू Z2 Z3 करो, R1 प्लस j omega L1, Z4 इज इक्वल टू R2, ऐसा करके जाओ, इक्वेटिंग रियल एंड इमेजिनरी, आपको क्वेश्चंस आ गया। सो दिस इज द R1 एंड दिस इज द L1। सो दीज आर द अननोन कंपोनेंट्स माय डियर। So these are the unknown components. Okay, so test coil क्या है? Test coil, this is test coil L1 and R1. So Q is equal to omega L1 by R1. So L1 is what? L1 is this L2 R3 by R4, and R1 is what? R2 R3 by. So if you see the Q factor of a coil, we got it. Q factor of a coil by the known parameters we got it. Q factor is one of the important metric. Q factor is the important metric. Q factor is the important metric. Okay na? Q factor is the important metric of a particular coil. Okay, chalo, let us go for the next question. Maxwell inductance capacitance bridge देखो, इसमें difference क्या है? Just the test coil, these are our unknown parameters. R1 we don't know, L1 we don't know. So to know this, we are using this setup. So which is nothing but this is the R4 and this is the C4. ये R4 C4 हमारा variable components है. Okay. So Z1 हम ऐसा लिख सकते हैं R1 plus j omega L1. Z2 I can write it as R2. Z3 I can write it as R3. But whereas Z4 is a parallel combination of R4 and C4. So R4 in parallel with 1 by j omega C4. I can write it as R4 by 1 plus j omega C4. So if I write comparison and if I solve, I am going to get some complicated equations. So Z1 के place में ये लिखा, Z4 के place में लिखा, and I am comparing the real and imaginary. So this is my R1 R4 combination आ गया, and this is my L1 combination आ गया. Okay, so test coil का Q factor, if you see, test coil का Q factor omega L1 by R1. So if you substitute test coil का Q factor omega R4 C4 आ गया. That means हमारा test coil का Q factor find out करने के लिए हमारे पास R4 C4 होना चाहिए. अगर C4 का वैल्यू ज्यादा है, Q factor का highest test coil का Q factor suppose is very high, that means more than 10. So if you want to find out the Q factor of the coils whose Q factor is very high, then it's highly impossible, because the C4 is a man-made capacitor. C4 is what here? C4 is a variable capacitor. So you have to use the highest capacitance. So highest capacitance design is very difficult, right? C4 should be high. That means C4 is nothing but epsilon A by D. उसके लिए overlapping area ज़्यादा होना है, distance between कम, ये overlapping area ज़्यादा होना तो geometrically बहुत सारा place occupy करेगा. That's the reason why Maxwell inductance bridges are suitable only for medium Q factor measurement related coils. Maxwell bridge, either it is an inductance bridge or it is a capacitor, Maxwell inductance capacitor bridge, both are best suitable for the measurement of inductance of the coil whose Q factor is medium Q factor. Is it clear, my dear? Whose Q factor is medium Q factor. So they are suitable for medium Q factor only. Medium Q factor. Medium Q factor measurement. Is it clear, doston? Anybody, any doubts, you can ask me. Is all okay from my side and from your side? Chalo. So that is the point of the Maxwell inductance capacitance bridge. So next let us go for the Hayes bridge. So next bridge is the Hayes bridge. If you see the Hayes bridge, this is a Hayes bridge. So this is a test coil. So the interesting thing of the Hayes bridge is in Maxwell inductance capacitance bridge, the fourth component R4 and C4 both are in parallel, but here R4 and C4 both are in series. Okay, so L1 R1 find out करना है, same to same combination. Z1 is nothing but that one, Z2 is this, and now if I go for the writing, so थोड़ा सा complication आ रहा है इधर. L1 equation ऐसा आ गया and R1 equation इतना बड़ा complication. These all you leisurely you can see. You can take the notes from this class होने के बाद आपको ये notes भी मिलेगा. तो थोड़ा mathematical adjustment करने के बाद हमको इतना बड़ा expressions आ गया. Okay. Thank you, 𝐂𝐚𝐿. Okay, so Hayes bridge is somewhat complicated. Okay, Hayes bridge is somewhat complicated. Finally हमको expressions क्या आएगा? So finally हमको expressions ये आएगा. So these are our expressions. This is our expression of R1. This is our expression of R1, and this is our expression for L1. So it is best suitable for the coils whose Q factor is greater than 10. Why? Because if you take this 1 by omega R4C4, okay, as a Q factor, suppose if I take omega R4C4, if I take common, they are going to get cancel. Okay, so then what happens? If it is highest Q factor, then only this value can be comfortable. So Hayes bridge is suitable for high Q factor measurements. It is suitable for, see, Q factor, if you check omega L1 by R1, मैंने L1 को वैल्यू सब्स्टिट्यूट कर दिया, R1 का वैल्यू सब्स्टिट्यूट कर दिया, सो हमको क्या आएगा? Q इज इक्वल टू 1 by omega C4 R4 आ गया. Q is equal to 1 by omega C4 R4 आ गया. So that means if you check here, when this simplification is possible, if you check L1 का expression ये है ना, तो यहाँ आपने suppose if you can write this 1 by Q, okay, 1 by Q. So why? Because Q is equal to 1 by omega RC. So if you write 1 by Q, if Q is greater than 10, I mean to say here, if Q is greater than 10, this is a 1 by Q, na? Are you following this point? Q factor का formula क्या है? Q factor का formula, Q factor is equal to omega L by R, or Q factor का formula 1 by omega CR. Okay, so this omega CR, if I write 1 by Q, then if Q is very very high, then L1 will be simplified. If Q is very very high, okay na? So that's the reason why Hayes bridge gets simplified expressions when the Q factor is very very high. Okay, you understand? Is it clear? So Hayes bridge is suitable for Hayes bridge best suitable for higher Q factors. Okay, my dear, is it clear? एक क्वेश्चन मैं देता हूं अभी आपके लिए. Try to solve this question. That is the last question we'll do, and with that we'll wind up the session. Yeah, try to answer this question. Sir, in batches you will teach it again? In batches? Kaha? Live में? In live, in app classes? Yes. In batches I will teach again, for paid batch, in detail. Yeah. In an AC bridge circuit shown in figure, at balance, the parameters of the coil are calculated to be 50 millihenry and 20 ohms. Another coil is connected in parallel to the previous coil, and the balance is restored by the changing R2 to 2.5 kilo ohms. The parameters of the new coil are dash. सोच के बताइए, IISc बैंगलोर 1996 का क्वेश्चन है, IISc बैंगलोर 1996 का सवाल है. थोड़ा सा कॉमन सेंस यूज करो. 2 minutes टाइम आई एम गिविंग फॉर यू. ऑप्शन बी बोल रहे. चलो कैसे करना है क्वेश्चन को देखो. सिंपल यार, बैलेंस के लिए क्या है, Z1 Z4 मस्ट बी इक्वल टू Z2 Z3. सो इफ यू सी दिस क्वेश्चन, Z1 Z4 must be equal to Z2 Z3. Okay. If in an AC bridge circuit shown in the figure, at balance the parameters of the coil are calculated to be 50 millihenry and 20 ohms. Okay, so this is the coil, test coil. The test coil means like this. So it is balanced when it is 50 millihenry, this is 50 millihenry and this is 20 ohms. Another coil is connected in parallel to the previous coil. So definitely क्या होगा, when it is like this, it is balanced. Okay. Another coil is connected in parallel to the previous coil, then immediately क्या होगा, this will become Z1 by 2. Z1 by 2. Another coil is connected in parallel to the previous coil and balance is restored. So is it going to be balanced now? Actually, no, it is not going to be balanced. It is not going to be balanced. If it is a previous case, as it is, we keep like that, it is not going to be balanced. Am I right or not? क्या हो गया? When will you start for ESC? Sure, I will start, my dear. ये क्वेश्चन तो आंसर करने दो. Yeah. So once it is parallelly kept, no need to go for mathematical adjustment. कुछ भी नहीं है adjustment करने का. So क्या बोल रहे, when it is 50 millihenry and 20 ohms, this is a scenario. Another 50 milliohm and 20 millihenry and 20 ohms coil is connected in parallel. Once it is connected parallel, it becomes by 2. Z1 by 2 and Z4 is not equal to Z2 Z3 obviously. But again a balance adjustment करने के लिए क्या किया उन्हें, so इसको Z1 by 2 and Z4 को कैसा कर दिया, balance is achieved, restored by changing R2 to 2.5 kilo ohms. So this one is reduced to 2.5 kilo ohms. That means it is changed now Z2 dash to Z3. So the parameters of the new coil are dash. When it is possible, it is, that means what it is happening, it is exactly possible Z2 dash is equal to Z2 by 2 into 3. That is possible. That means the new coil whichever is kept in parallel, so that is also same. That is also same. Then only it is possible now. So he is asking what values will be the coil which is kept in parallel. So the parameters of the new coil is asking. So he is asking the parameters of a new coil. It is possible only if this and this both are parallel same, then it will become half. And then if you make this also half, then it is balanced. That's the reason why option B is right answer. Very, very good question. Conceptual questions. All of you understood or not? Very, very good question. Conceptual question. No need to solve by using paper and pen. Enough for today. Any other doubts you can ask me? चलो, any other doubts you can ask me, no problem. मैं वाइंड अप कर रहा हूँ यहाँ से. ओके, कल और कुछ क्वेश्चंस हम डिस्कस करेंगे. If you have any other doubts, you can ask me. Okay, so in tomorrow's class, remaining bridges we'll discuss. Okay, thank you. In tomorrow's session, we'll discuss remaining questions. If anybody is having any doubts, they can post here. Any doubts? Anybody any doubts? ESC का भी session start करेंगे. Soon we'll start the session. Yeah, मजा आ गया किंगस्टन. डेली 1 hour 10 minutes 1 hour 15 minutes ऐसे करके जाएंगे. जितना सेशंस होगा उतना तक कर जाएंगे. Okay, if you have any doubts, you can ask me. Any other doubts, not only this subject and any career related doubts also you can ask me. Anybody is having any doubts, please post there. Okay then, thank you. Bye. Thank you, Kingston. We'll meet tomorrow. Same time.